As a skippered charter boat, Confidence didn't really need an autopilot because we always had crew around. But since COVID, we've been short-handed and we've not had any guests on board, or very, very few, and we've stopped skippered chartering now almost permanently. So at the moment, there's just two of us, and that we need another pair of hands. So we decided to invest in a Raymarine EV100 autopilot, and I'm going to try and fit that today. There are lots of videos about how to fit it already, so I'm not going to try and repeat what's already out there, but show some of the unique challenges of doing it on this boat. If there are any, we'll see as we go. Now, for ease of installation on something like a 34-foot boat, which is what Confidence is, you can use a thing called a wheel pilot. What this is this plastic disc clamps to the wheel, and then there is a drive motor here, which then turns the wheel. And if you don't want to use the autopilot, you leave the lever unengaged so that the drive unit can slip round and the wheel can turn normally. And then if you want to engage the autopilot, you clamp the wheel on, and then the computer controls the motor and then turns the wheel. So, having spent several days reading the various pieces of literature, it seems the most important part of the installation is planning where you're going to put everything. So you've got to think about the magnetic interference, both for the units and for the interference it gives to your compass and other things. You've got to make sure you've got enough electrical power available, the right fuses and cables, which we have, and you've got physical space as well to put all the boxes. So the biggest part of it is planning, and some of it is very difficult guesswork because you can't always work out where everything's going to go to be comfortable to operate. But we're going to give it its best shot, and hopefully we're going to not make any mistakes. Having watched some of the other installation videos on this product, it seems to be the challenge is around fitting it on this plane here. We're quite lucky this is flat, but what we might not have is enough depth behind the wheel. Now if we don't, we'll have to take some kind of bush and push the wheel out, reduce that down. The control head's going to go there, and there's already a hole for a previous piece of instrumentation. I've just taken that out, so we're just going to make that hole a little bit bigger. Now for anyone who's taking one of these off, this is the ultimate bit of care is required when removing the wheel. So if you've never taken a wheel off, most of these wheels are the same sort of thing. There is what's called a key inside, and the problem with the key is it's loose. So when we take this off, you've got to make sure you don't knock this out. The one on here is quite small, but on some of the other wheels it's a little bit bigger and it's easy to drop it out. So I take the wheel off nice and carefully. There's the key, and if you see, that's just resting in there, and that's the same as on most wheels, so you don't lose that. One of the frustrating things about this pedestal is the fact that in order to access this panel, to remove this panel, there's no screws. You have to cut out the sealant here and then pull the whole thing out. There we are. So let's have a look how much space we've got inside the binnacle to see what steps we may or may not have to take in order to fit this autopilot. So this is what the hole for the compass, so it's quite decent size. That's the hole for the instrument, so the old instrument has been taken out, you can see the shape of that there, and this is the template drawn in for the new one, so we've got to cut these little bits out. And then down here inside the binnacle there, now I'm going to do something I can't do with my own head, which is look. So one thing we've got to fit is the P70, the control head, or the so there you go, that's the back of it, that's the profile, that's the shape, and that's going to fit in there. So the basic principle of how an autopilot works is it takes the boat's heading, and when the bow starts to drift off that heading, it adjusts the rudder so the boat comes back onto that heading. And the usual way that it knows what the heading is it uses an electronic compass, like one of these. Now this is a Fluxgate compass, and the problem with using just a compass is that when the boat is rising and falling on the waves, the rudder can't always compensate quick enough to get back on course. So Raymarine's answer to this is this, the Evolution EV1 Sensor Core. Now this thing doesn't just do heading information with a compass, it also does pitch and roll and yaw, and so it can sense on 6 axes and heading as well, which means it can feed information into the computer can then do the working out how much rudder to apply, and then the motor applies the rudder. Nice and simple. The restriction with that is that we have to mount this relatively flat, so it's got to be within 5 degrees of the boat being flat, so we're going to have to use a spirit level on a boat. That's a novelty, and it's got to be, there's an LED little arrow which lights up apparently when it's going, and that LED has to be along the centre line of the boat. Now we are lucky in that despite the restrictions in where we've got to put this thing, we can't have any electrical interference near it, or radio or compass interference either, is Raymarine have thought that through, and they've provided us with a variety of brackets so that we should be able to pretty much choose where we're going to put it and then mount this in the right place. The problem we have to do is find a place to put it on the boat. And there is the steering. So that's the wire from the bottom of the pedestal, and it's going up to the back. Feed the cable for the sensor through this, and clamp it up accordingly. And while we're here, we can grease that cable. That looks a little bit dirty, so I think what we're going to have to do is leave this off, and then pull the steering through and degrease it, and then put some new grease on. But that's a different job for a different project. Right, so we've pulled the cable through from there into the locker. Now this is a backbone cable. It's blue as opposed to the drop cables, which are white, and this is also the terminator. Now on the end of any backbone you need a terminator on each end of the backbone. So what we've done is terminate there, backbone cable to here, and then here the other end, there it is. And what we're going to do here is we're going to do the termination thing here. So that's the backbone and then the terminator, and then that's the drop cable, which can then go into the sensor. So my theory is that this should be flat. So I've glued on a piece of wood, and that should be flat to the boat, so we can use that as the bracket to put the sensor core in here. And then obviously we've just pulled the cable through and added the all of it, and there's the drop cable. So we'll put the bracket onto that, glued it on. There's no weight to it, so it's just normal, no nails, glue from Screwfix, and we'll drill we'll screw the bracket into this, and then we can then plug it in. But that means that this has got nothing round it, and we don't use this locker for very much anyway. There's nothing here, and we don't come in and out of this locker much, so we're not going to damage it. But also it means we can get to it to check the LED to see if there's any faults on it, which is apparently important. Final part of the installation is to find a suitable location for this, the ACU, Actuator Control Units. Don't quite know why this needs to be mounted vertically. That will pose us with more of a problem than we perhaps needed, but we've got to find a place for that. So I like the fuse there. So it seems power goes into that one, and then the motor goes into that one, and then the C-torque cable goes into that one, the rudder thing we haven't got. Another squeeze of no more nails and 2 other little bits of wood glued onto the inside of the back of the pedestal, and that seems like a good place for the ACU. One of the tasks we have to do first is to fit this outside piece to the wheel, and it depends how many spokes your wheel's got. We've got 5, and so what we need to do is we need to get these little brackety things and fit them to the outside of this. That way, I think. And we are given a series of holes here which depend on how many spokes you've got. You drill them out, and that gives you the locating holes for the brackets, depending on how many spokes. Because we've got a 5-spoke wheel, we've got to locate all the holes with a number 5 next to it and drill those out. So in the pack, the good people at Raymarine have provided us with a 6mm drill bit to drill the holes, which makes life a bit easier. What they haven't done is they haven't given me a bigger drill bit to clear up the swath. So there you go. Not only do you can you choose how many spokes you've got, you've also got a choice of diameter of spoke. Measure your spokes and choose the rubber insert that is best suited for the job. Put the correct rubber insert around the spoke, then stick on the clamp and screw it up. And tighten up with the Allen key provided. So we're doing a basic wiring test now. The hub's down there. The sensor has a light on it in there. I think we can see the sensor there. There's the green light, the LED at the front. And the motor's rigged up over here. So if we press the auto mode, we should then be in a position for it to work. If I then go over there, press the +10, and there she goes. Off she goes. Brilliant. So we now are working. Cardboard template to show us where the hole will be, and then if we check where the that side, there's plenty of clearance. It's not going to hit anything, so that wire's not going to be there. Okay. Not enough clearance. Well, there you go. Disaster has struck. So it was always a risk that we wouldn't have enough clearance for the unit between the wheel and the pedestal, and there's not really any way of measuring it because of the various complexities of any measurement, and we are only a couple of mil out. So
what we're going to have to do is move the shaft, the steering shaft, forward a little, and we've got to strip it down a little bit to see how easy that's going to be. I suspect we'll be able to put some shims in, but we might not be able to actually make it work today, because I think we're going to need to actually make some or get some proper ones made up in order to do it properly and safely. We might be able to bodge it so that it'll work today, so let's see how we get on with that. Well, the good news is it's on. The bad news is it's a bit stiff on the steering. So I shimmed it up with 2 washers there and 2 washers there. That's brought it out enough so that it actually does clear everything, although it could do with being a bit further out. But if you put it across and give it 10, seems to work. We're back home, and we're going to look at fixing this bracket and putting a shim so that we can move the steering forward to allow room for the autopilot. So this is the back plate from the back of the front part of the steering. So all we have to do with this is duplicate that, whilst this piece is the back. So that's the back of the steering, and the steering shaft goes into that bearing, and this bearing spins round. So if we move the steering shaft forwards, which is what we need to do to get the clearance, this bearing also needs to come forward.
For the back plate, I'm using a sheet of high-density polyethylene, HDPE. It's an engineering thermoplastic which is easy to machine and won't degrade due to either saltwater or sunlight. It's really cheap and easily available, so it's ideal for this kind of part. After rough cutting with a saw, I'm using a cutting tool on the lathe to round the corners off. HDPE can be machined at high speed, but it does melt a bit if you overdo it, so you have to be careful and keep the part cool. You might have noticed that the drill was on a fairly slow speed earlier in order to avoid it getting melty. So these are the finished shims, same shape as the backing plate, and I've made 3 of them. So remember, that's the back bearing off the steering. So when we bring the whole steering column forward, or the steering shaft forward, the shaft's probably going to fall out of that bearing. We need to make up something to extend this out. Now, I've already made this up, which was a piece of Delrin, and I've chopped it to that length, so it's a bit longer. And what I've done is I've drilled a big hole in the middle. And what I'm going to do is we're going to go and get a bearing that's 25mm internal diameter, which will fit the shaft, and then we're going to mill out the inside of this so that we can then put the bearing inside it, and then we need to make a back plate so that we can fix that up. So we took our bearing down to the local bearing place, and we've got this. Key thing was to make sure that the internal diameter was 25mm. The outside diameter wasn't important, neither was the depth. We know there's no real load bearing. The only thing was it had to be stainless because it's going into a marine environment. So I'm going to have a move over to the drill press to do the 6mm holes. Because we used a countersunk screw, we're going to use a countersunk bit to, countersink it. So we've got 4 holes, 6mm holes for an M6 bolt, and we've countersunk them. But we're now going to drill holes in here to take that bolt, and we're going to tap them. So you can't use a 6mm for an M6, you need to use a 5mm drill so that you've got enough room then to put the tap through and actually get threads on it. So that'll be the M6 thread that'll fit that M6 bolt. Unlike the HDPE I use for the backplate, the Delrin is great to machine and doesn't get as melty when drilling or cutting. It's a bit more expensive, but thankfully I had some left over from when I made the parts up for the ends of the bowsprit for the spinnaker. So we're going to do a manual process, but we still need a machine to keep us on the straight and narrow. So I'm going to use this centre in the mill to provide a proper centre guide to make sure that we are straight when we are tapping this hole. So there we are, we're resting that in, and then we'll start the tap. So now we've done it, tap the hole, we can do that, which is good. So there she is, tapped in, and then we can use that first one to drill out these others, and then tap the other 3, and we'll know that the 2 pieces will be together. So now we've got to make sure the inner piece aligns with the outer piece, and we can use this as the template, the original. So what we've done is, using the original cross hatch lines there, I've drilled a hole in there which matches up with that one, so those are manually lined up, and I'm going to just bolt through so that I can put it on the drill press, and then we can line those up and we know we're going to make those holes in the right place. Okay, happy with the hole. Drill through and done.
Awesome, awesome.
Yeah, the other point is we haven't really gone off this course very much, have we?
No, no. Well,
They did say you had to swing it around a